Alright, so in a change of state from solid to liquid, if a state changes from solid to liquid, it is basically known as melting. If it changes state from liquid to gas, it is known as boiling. So basically both of melting and boiling, they occur when we provide it heat. They occur when we provide substance heat energy. So upon heating, if there is a solid, it will be converted into liquid, and if it is a liquid, it will be converted into gas by the process of boiling. Alright. So upon cooling, so if we cool the substance, let's say from gas to liquid, and if it is converted from gas to liquid, so then it is known as condensation. It is known as condensation. Alright, so if it converts from liquid to solid, it is known as freezing. Alright, so melting is basically change of substance. It is the change of state from solid to liquid. It is a change of state from solid to liquid at a constant temperature. At a constant temperature, which is known as its melting point. Melting point. So basically, let's just take an example of ice. So what happens when ice, if we have a pure ice, it melts at 0 degree Celsius. So 0 degree Celsius is a constant temperature. Constant means like one fixed value which does not change. So ice basically melts at 0 degree Celsius. So 0 degree Celsius is the constant temperature over here, and which is known as its melting point. Whereas freezing, so freezing is basically change of state from liquid to solid at the same, it occurs at the same constant temperature. Which is known as its freezing point. That temperature is known as its freezing point. Alright, so basically at the same constant temperature, for example, what happens if ice is melted at 0 degree Celsius? If ice is melted at 0 degree Celsius and it is converted into water, so what happens if we need to freeze that water again? So we will lower the temperature, and at 0 degree Celsius it will be start converting into ice. So that's why, so the point to note over here is, if a substance melts at a specific temperature, it will also freeze at that specific temperature. For example, in the case of ice, if it melts at 0 degree Celsius, so it will also freeze at 0 degree Celsius. It is because so why does the temperature not change during a change of state? Why does the temperature stay constant? Alright, so basically temperature remain constant during a change of state because the heat is being used to, the heat which is provided is being used to break the intermolecular forces of attraction between the particles. Alright, so basically what happens, the temperature remain constant because the heat which we are providing, is being used to break the intermolecular forces of attraction present between the particles. So that's why it converts the state. For example, intermolecular forces of attraction is simply the forces of attraction between the molecules. For example, in the case of ice, so particles of ice are tightly packed together due to the forces of attraction which is known as intermolecular forces of attraction. So when we provided heat and at 0 degrees Celsius, what happens? The heat which we are providing it is being used to break those intermolecular forces of attraction. That's why the temperature does not change at that scenario. Alright, so in the opposite case, like in the case of freezing, what happens? Particles need to join up together. Therefore, temperature also remains constant because now the heat taken out is being used. So to break the forces of attraction, we provided heat. To break the forces of attraction, we provided heat, and to again rebuild those forces of attraction, we take out that heat. So what happens? The temperature remains constant in the scenario of freezing because now the heat taken out is being used to build the forces of attraction between the particles. That's why the temperature do not change in both scenarios, whether it is melting or whether it is freezing or any kind of change of state. So whenever there is any kind of change of state from melting like in the case of solid to liquid, or from liquid to gas, or from gas to liquid, so whenever there is a change of state, it always occurs at a constant temperature due to this reason. Alright, so further, boiling. So boiling is basically a change of state. It is a change of state from liquid to gas. Change of state from liquid to gas at a constant temperature. Again at a constant temperature, which is known as that temperature is known as its boiling point. For example, pure water boils at 100 degrees Celsius. So 100 degrees Celsius is basically boiling point of water. It is boiling point of water. Boiling point of water. Alright, so condensation is the change of state from gas to liquid. It is the reverse of boiling. It is the change of state from gas to liquid. At the same constant temperature, which is known as its condensation point. Condensation Alright, so basically whenever a substance change state, the number of atoms the number of atoms in that substance do not change, right? So whenever there is a change of state, the number of atoms would not change. So therefore, mass will also not change. So therefore, mass does not change. Alright, so change of state is always a physical change. Change of state is always a physical change, not a chemical one, not a chemical change. Because what happens, the material recovers its original properties if that change is reversed. If that change is reversed. So far in this video lesson we have learned melting. Melting is basically change of state from solid to liquid at a constant temperature, which is known as its melting point. And liquid to gas, it is known as, we call it boiling. So boiling is a change of state from liquid to gas at a constant temperature, known as its boiling point. So if there is a change of state from gas to liquid, that is known as condensation, and at the temperature at which it occurs, it is known as its condensation point. And if it goes from liquid to solid, so that is known as freezing, and at the temperature on which freezing occurs, that is known as its freezing point. So further we discussed why the temperature do not change during a change of state. So basically, in the first scenario, when we are providing heat, in the case of solid to liquid or from liquid to gas, so what happens, the temperature which we are supplying it is basically during a change of state. For example, ice at 0 degrees Celsius. So what happens, we are giving it heat and it is not showing any change in temperature on the thermometer. The reason to this is because that heat is being used to break the intermolecular force of attraction present between the particles. Whereas in the reverse scenario, if we go from, like in the case of liquid to solid, solid, so what happens in the case of freezing, what happens, so the temperature do not change on a thermometer during a change of state, because the heat taken out, now the heat taken out is being used, it is being used to build up the forces of attraction between the particles. That's why the temperature do not change in both scenarios. Alright, so further we discussed, whenever there is a change of state, number of atoms in that substance do not change, right? So mass does not change as well. Further, afterwards we discussed change of state is always physical. Change of state is always a physical change, not a chemical change, because the material recovers its original properties if the change is reversed.